the next thing that we're going to look at, the next relationship that we're going to look at with sets is going to be the intersection of sets. So the intersection of sets A and B, symbolized A, and this looks like an upside down U, because we're going to use a U to mean something else. So symbolize the A, this is our symbol for intersect B, is a set containing all of the elements that are in common to both set A and set B. The word and is usually interpreted to mean intersection. So complement, we said, meant not. Intersection is a word that means and. Right? So looking at this Venn diagram here, I'm just going to shade in the area that represents our intersection. So it's the things that want to be in set A and in set B. So that's going to be where they overlap. Just like the intersection of two streets, right, is where the streets cross each other. It's where they overlap. The same thing is true when we're thinking about sets. So where A and B overlap, the elements that are in both, that's our region 2. Right, using our Roman numerals from the previous page, which is this area right here. Right, so this middle area represents our intersection. Again, if we want to write it out in proper notation, right, we put A, and then we put an upside down U and B. So that is our intersection. In this next example, then, we're going to go through and just kind of use this definition a little bit. Right. So we're given our universal set. It contains the natural numbers from 1 to 10. A is set 1, 2, 3, and 8. B is set 1, 3, 6, 7, and 9. And C is our empty set. Right. And so we're going to be asked to, if we look at this, find a bunch of different intersections. All right. So A intersect B is our first set. We're going to put an equal sign here. We're going to start a brace for our set, and we want anything that's in set A and in set B. Well, if we look at this, we see the number 1 in both sets, so we're going to put that in our intersection. 2 is in set A but not in B. 3 shows up in both sets. All right. 8 does not, and then in set B we have 6, 7, and 9, which are not in set A. So our intersection A intersect B is just the elements 1 and 3. Right, A intersect C. So again, A is 1 through 8, C is the empty set. Well, C has nothing in it. So if we intersect it with another set, there is going to be nothing in that intersection because this has nothing to overlap with this set. So since we're intersecting a set with the empty set, our answer is simply going to be the empty set. Right. As we continue in this example, looking at the next one then, we're asked for the complement of A intersect B. So the first thing we want to do is we want to find our complement of A. Right, so that's the first thing that I'm going to do in this problem. Right, so just right underneath here, I'm going to write a little note and say that we are going to use the complement of A equals. Right, so our complement of A is going to be anything in our universal set, so any of our natural numbers from 1 to 10 that are not contained in this list. Right, so A starts out with 1, 2, 3. Those are in A, so they're not going to be our complement. But 4 is not in set A. Right, so the complement of A is going to be 4, 5, 6, 7. 8 is in A, so we're not going to use that. 9, and 10. So there is our complement of set A. All right. Now we're going to compare this set here to set B up in our original list. So I want anything that's in this complement of A that we just found and is also in set B. Again, we're thinking about the word and, we're thinking about where they overlap. Right? It's in both. Right? So we can look at either one of these. 1 is not going to work because it's not in our complement here. 3 is not going to work because it's not in our complement. But if we look at these other 3 elements, 6, 7, and 9, notice that they are both in set B and in our complement of A. Or we can start with our complement of A and compare it to B. It doesn't matter which one we start our comparison with, as long as we're looking for the elements that are in both. So the complement of A intersect B is going to contain 3 elements, the elements of the numbers 6, 7, and 9. All right, then for D, notice that we have something in parentheses. Just like we do when we're thinking about order of operations, we're going to think about what's in those parentheses first. Right? So inside these parentheses, we have A intersect B. And remember that that was answer A. So in this case, we are going to use the answer to part A. Right, so A intersect B, the things that were in both of those sets were 1 and 3. Well, now what we want is we want the complement of that. So we want anything in our universal set that's not in this list. So this is our universal set. We want to pick out everything in this universal set except for the numbers 1 and 3. So our intersection here is going to be 2, 4, 5, 6, 7, 8, 9, and 10. Right, so what we have in that set is everything in our universal set, so all of the natural numbers between 1 and 10, aside from the numbers 1 and 3. Right. So again, intersection is the overlap, intersection is the word and we also used a little bit of our complement in here as well. And our complement again meaning the word not.